So my name is Jeff Garland. I'm going to try and do an interesting thing today. It's a little different. We have 1 hour. C++23 cannot be, just library cannot be talked about in 1 hour. It's impossible. So what I'm going to try and do is give you the top 5. What you see here is the entire presentation. What's hard to see, it's a little off the slide, is there's 150 slides in this deck, okay? Which is an incomplete deck because there's certain things that are going to be in C++23 standard library that I don't have really fully covered here. I'm not going to tell you what those are, but when we're voting for whatever it is, I might help guide you to the parts that are really good in the talk versus the parts that are not so great. So let me give you a little bit of an intro. What is the status of C++23? Well, it's going to ship on time, which means it's going to ship this summer in CD form. This is an immutable part of what the committee does now. It's called the train model. Every 3 years, a new standard ships. That's what we do now. There was a plan for C++23. Some parts of that plan got executed. Some parts of that plan did not. All of the committee work for C++23 was basically done virtually, except for things that were in the pipeline ahead of C++20. Obviously, that's due to COVID. For many of the groups, they're meeting every week, subgroups, especially on the library side. Library Evolution, Library Working Group, we have meetings every week. And then there's 3 virtual plenary sessions where final votes are taken, which is the standard committee process, which normally would happen face-to-face in week-long chunks 3 times a year, but instead now done virtually. So that's the adaptation that we made. I will say that as an overall theme, you'll see, I think, that the library is a much bigger component of C++23 than the language side of things. I think in part that's because of the difficulty of evolving the language in a remote setting. There's a lot of very complicated discussion, whereas library, maybe it's a little easier to do that. So this release, I think, its best analogy is C++17, which was actually a pretty library-heavy release without so many language features. Okay, so here's where we are. We're literally weeks. We're within 40 working hours for library working group to finish wording stuff and shipping the CD. So it's late June, early July when that's going to happen. And once that happens, it goes through the entire ISO process of national bodies reviewing, submitting bug reports, us fixing those bug reports, submitting another CD, and so on and so forth. And then in late 2023, you'll see the approval. The design is done. It's fixed. Oh, CD. It doesn't stand for a CD like a CD, right? It's a committee draft. Thank you. Thank you, David Olson. Yes, committee draft. So it's the final working draft. Most of what I'm going to talk about in this presentation today is already in the working draft because it's already been put in. Where it's not in the working draft, or where it's in, stuff that still needs to be done, I'll tell you about it. And I'm not going to promise anything because at the last minute, it's always possible some objection could be raised.
So
yes?
The easy way to think of the CD is it's the beta release of the standard.
So Marshall just said it's the beta release of the standard, the CD. Okay, so the priorities for C++23 library, bug fixes, you might be surprised to learn it's actually a huge priority for us. And of course, everything was 100% right in 20. It was a massive release. We didn't make any mistakes whatsoever. So, here we are. But actually, a lot of mistakes were made, and I'll talk about some of those today if that's what we want to talk about. But during this cycle, incompatible changes were made to format and ranges. Actually, let me ask the question, who in this group uses format and ranges in one form or another? Nobody's using format? Let's do format first.
Hold on, not FMT format.
FMT, yeah, well, FMT or STD format.
They affect format, not FMT.
They affect both. So the question was, what does it affect just FMT? So if you use FMT or format, raise your hand, please. Okay, so that's probably about half this room. And some, sort of, kind of. If you use ranges v3 or std20 ranges stuff, smaller, maybe 25% of the room. Okay, so most of you won't notice what happened in terms of the ranges. You'll notice in terms of the format, because that was radically different. And so I'll probably talk through that one no matter what. So concurrency support, the big one there was STD execution. That is probably on the docket for 26. Networking off the docket, and support for modules. That's one we can talk about. That one is coming. Coroutine support, STD generator, that's synchronous coroutines. That one is in process. Maybe, maybe not. We will see if we can finish the wording. So there's a ton of features to ranges, a ton of features to format, and really when you look at it, also the way the 20 cycle with the large release that it was for everything, there was a lot of stuff to mop up. And so at the beginning, LWG spent probably the first solid year working on stuff, and there's still things from that cycle that we're trying to finish right now before the end.
How's P805 going?
What's P805?
It's my paper that Wakely took over.
Oh, it's not going.
I was pretty sure it's not,
Yeah, it's not going anywhere right now.
because he hasn't done anything.
Jonathan's a little busy, so among other things. Okay, so as I said, 95% of what I'm going to talk about is, probably already in the working draft, and I'll tell you where it's tentative. I'm going to ignore a lot of things here. There's small bug fixes and so forth that aren't even in the 150 slide deck, and I'm going to kind of just not talk about freestanding. I don't know whether freestanding is going to get in or not. We're trying our best to get it in. But really, freestanding doesn't change anything. It just says what are the subsets of the standard library that are required for freestanding. It doesn't really change the standard library itself. And if you're interested in that, you can certainly ask me about that later on. Okay, now in the next, let's see, how many minutes in am I? Okay, I'm already 10 minutes in. So I'm going to have to go faster. So I'm going to have to talk really fast now. So I'm going to tell you everything that's in C++23 in 10 minutes or less, as best I can, and then we'll talk about what 5 things, or however many we have time left for, we can actually talk about in some detail, look at code examples, etc. So no code, nothing but some short explanation. Basic string contains. That's the simplest function in the world, one function, you know what it does. String and null pointer. You can construct a string from a null pointer before C++23. You cannot in C++23 and beyond. That's surprisingly important. Resize and overwrite for strings. This allows you to overwrite a string in cases with your own callback function. String and actually string view range constructors, those are pretty important as well. Okay, so that's string processing. Oh, by the way, these are divided up into categories, of relatively important things. Module support. There's basically one feature here. It's modularize the standard library, improve compile times, make your life better. Yeah, I see a little bit of cheering in the back there. That one's going to go in for sure. Math support. David Olson is here. He wrote the proposal for extended floating point types. Mostly that's smaller floating point types and one big floating point type. But there's some optional support for that. Constexpr and CMath. Well, that fits in another category too, which is Constexpr all the things. Atomic min and max functions, and MD span, so multi-dimensional span, which allows you to provide a view over contiguous data structure. So if you're doing any kind of numerics where you're processing matrices of various forms, maybe you're sending something into Fortran, maybe you're sending something into not Fortran, you might want to be able to look at your data structures in different ways. Okay, that's what's in math support. Coroutine support, standard generator. It's a synchronous recursive coroutine generator. If you've not played with coroutines, to use coroutines even in a synchronous way requires a decent amount of boilerplate code, and this facility takes care of that boilerplate for you. It generates the boilerplate. Get the joke? Yeah. Okay, bad joke. So it's in a header generator. It's not in the working draft, so, we'll see. I think it's going to get in, but I can't guarantee it. So I/O is huge in this release. I think this is probably, when I step back in and look at the I/O additions to this is one of the most significant things. In 2007, at this conference in Library in a Week, we worked on a library to print containers. You can print containers in C++23 with a single line of code in an awesome way. So it only took however many years that is in Delta for it to actually happen. But it is going to happen. Also, if you've used format, STD format or FMT format, you're also going to now get print, which gives you an additional ability to go to additional things besides a string. So that's a very valuable addition as well. And the changes and additions are those bug fixes I was talking about, which really changed the nature of the API to more of a compile time error API versus a runtime error API. Spanstream, yeah, we're still putting streams in. Spanstream is the last nail in the coffin of the legacy I/O streams, the otherwise known as STR streams, that are pre-1998 that have never been removed from the standard as of yet. Because there's one feature that keeps them in the string stream, which is the ability to wrap around, say, a char array or something like that, and use that as your input and output. So Spanstream gives you that ability.
They've been deprecated since at least 03.
Yeah, so Marshall says they've been deprecated since basically the beginning, but they're still in the standard, and we would really just like to get rid of them once and for all. So I think you'll see that happen in 26. All right, so ranges. Ranges has got a whole bunch of changes to it. The split view, iStream view, and join view, as I said, mistakes were made. So there are significant changes to the way those work, including basically a rewrite of split view to do something completely different than what was specified in C++20. Ranges 2 is a facility to make a view into a container, but it's actually a lot more than that, because it also specifies all that the containers in the library now have range constructors, which is an incredibly valuable thing. More than that, they also have operations like insert range, append range, and so forth. So those are actually very interesting. And as I said, formatting, a massive addition to being able to format ranges. As I said, I think for day-to-day programming, this is probably the most valuable feature. Not to, bias the voting later. Pipe support for range adapters. Something very cogent was pointed out, that at some point, we're not going to be able to put all the views and all of the ranges, things that we want to, into the standard. So it would sure be nice if we could make user-defined ranges and views work like the standard ones and use the pipe support. I don't know, who uses the pipe operator kind of stuff? Okay, we got a couple. Okay, there may be some heavy suspicion of the piping operator and its efficiencies. But regardless, this is allow you to write a view and make it interoperate with standard views. That was not possible in C++20. It was underspecified for doing that. And then also another David Olson paper, being able to use the non-range algorithms with ranges views, which is another important thing. If you look at the ranges algorithms, you'll notice, for example, important things like the concurrent versions of the algorithms are not actually accessible in ranges, and you don't have range versions of that. So we'd also like to be able to use the range things in cooperation with those other things that we have in the library. So it's a compatibility fix, which I think is actually pretty important. All right, this is not going to work. Why I'm holding that. Okay, so I think I basically said all of this. There's a little bit of detail here about there's a plan and so on and so forth. And if you're looking into ranges and you want to start rangeifying code, I suggest Tina Ulbricht's presentation. You can find that on YouTube. Okay, So here's the list of new, so I should step back. Everybody knows, right, there's actually two components of the ranges library. There's algorithms and then there's views, as it were. And so algorithms are the lower level thing, and this is the set of algorithms I expect to see in C++23 at this point. So find last, Zach is here in the back, and he's actually working on a set of boost changes to it. It got evolved, but contains, again, just like the string contains, but just on a general arbitrary range of any sort. And shift left, shift right, those were things that we got non-range versions of. Starts with, ends with are also related kinds of predicates. And then in the ranges, views, and adapters, I think you can safely say that C++23 will kind of fill out that group to a level that it makes it more usable, basically, than what we had. Basically, the 5 or 6 things that we had in C++20. So adjacent transform, that one's already in. Zip, these guys at the bottom are already in. Well, actually, maybe repeat and slide are not yet. Cartesian product is not finished yet. So those are things that are on the bubble. Chunk and chunk by are zip and zip transform. This one's really nifty and cool, and actually super important for things like flat map. Const expr, all the things. So unique pointer is const expr. Variant optional, type info, operator equal, what do you know? Some small little gap that was missed somewhere along the line. Pretty important, CMath functions. Now you can actually write const expr math. It's not everything. So if we go through that section, I'll tell you what it's not and what it is. To chars and from chars, that's in italics. I don't know if it's going to make it. It's just a question of whether we have time to finish processing that paper or not. And that's for integrals only. So just only for integer types, no floating point. So ironically, we get CMath functions with floating point types, in const expr, but we don't necessarily get to chars and from chars.
Does that to chars and from chars come with S2I?
The question was, does the to chars from chars come from S2I? Come with S2I? No. They're different facilities, and I probably don't want to say on video my opinion of the various facilities, so I'll talk to you offline about that. But the one thing you can say with some authority is to chars from chars is by far and away the most performant interfaces the standard offers, and they were not easy to do. In fact, I think GCC just finished. I'm not sure what, I think Clang has them as well, and MF.
All the integrals, and there's pull requests out for the floating point.
For the floating point, Clang still not got the floating points. Yeah, she have.
Already. The floating point ones for each C++ are already finished.
Okay.
Except for the lambda.
Okay.
Which is the one that Microsoft doesn't do either.
Oh, Microsoft. Okay. So apparently there's still some gaps in to chars from chars, but it's an incredibly important facility. Its API is difficult to use, rapid. That's my advice. All right, containers. Flat map, flat set. Everybody knows what flat kind of containers are. Hopefully memory matters in 2022. Heterogeneous associative container functions. Wow, it's a handful. We got some of that in C++20. We're getting some more of it in C++23. I'm not sure we're getting all of it in C++23. I don't think we're going to get all of them done.
Are we getting transparent hashers, or just for like set and map and other containers that use comparison?
So the question is, are we getting transparent hashers? I think those were already in 20.
Oh.
Yeah. Yeah, those were in 20. The main one that's in 23 so far is erase, but there's also a whole nother set of operations that you want to do, right? And basically it's if your key values are comparable, essentially, right? That's essentially the thing. I mentioned earlier the range operations on containers. Those are nifty. All right. Utilities. My goodness, there's a ton of things here. Byte swap is a simple thing. It does exactly what you think it does. It's on integer types. Expected. Who knows about expected or has heard about expected? That one was floating around from 20, but is across the finish line and will be in 2023. So it's an error handling technique. It's a variant type. It effectively allows you to have a return value type and an error type. We'll see if we get the monadic functions. It may or may not happen. I'm not going to commit on this video. Is-scope-denume is a type trait. That's a very small thing. Monadic optional. So this is the ability to chain together a series of operations on an optional type. Stack trace, that's exactly what it says. It's boost stack trace, basically. Slightly different. To underlying, if you have an enum, an enum class, right? And you want to get it actually converted into the integer class, well, this is the easy way to do it now. And then unreachable is a way to actually mark a branch of code unreachable, which allows the compiler to optimize in certain cases. So a lot of these are small. Expected is pretty big. Stack trace is decently sized. Yeah. But these are all, I think, a lot of these things are actually really pretty valuable additions, small additions. In terms of function objects, we have invoke R. I believe Ji Hao is the author of that paper, and is part of basically another way, or I guess it was a missing part of STD invoke would be one way to look at it. We also have move only function. There's also function ref, which I don't know where that's going to land, and it's not on this slide for that reason. And also, as part of another proposal, there's bind back. So if you've been using bind front and you want to go the other direction, there's also going to be bind back. All right. And then I think last, interfacing with C. If you're writing atomic code in C, you can now use that in C++ efficiently or effectively in 2023. Out pointer, in pointer, this is a new facility that allows you to seamlessly manage C pointers using unique and shared pointer. So that's kind of an interesting new facility. We already talked about context per C math and extended floating points. So the extended floating point, by the way, I should have mentioned earlier, that's actually coming out of C. And there will be the corresponding types. The thing is, we have this little bit of a problem in that C23 is releasing at the same time as C++23. So we can't base the C++23 standard on the C shifting sans standard, so we can't really rebase effectively until C++26 on C23. However, David wrote the paper and worked with the liaisons and so forth to effectively make the wording reflect, and this was probably going to happen anyway because the folks that provide these two libraries are the same groups. They were going to use the C types in a way that was compatible with the C++ types. Okay, so I think that's it for the overview. So the question is, what do we want to dive deeper into in the remaining 66 minutes? Over here.
Question about Spanstream.
Okay, question about Spanstream.
So I recently had to dig into history books about how to use strstream.
Yes.
And the reason was I had to interact with a C API, networking API, that could free its buffer, that I could give any buffer to it with a free function, and then it could free it afterwards. So basically I was using strstream's release functionality.
Uh-huh.
So without sending something down the network without copying.
Right.
Is that achievable with OSTR?
So let me see if I can summarize the question down. Effectively, the ability to attach in that buffer and release that buffer that's coming out of a networking library or some other thing. Well, this isn't going to really allow you to do that exactly. You're going to be able to wrap a stream around a span, which may or may not be able to represent your buffer. Should be able to, STD span of STD byte might be what it would wrap around. But whatever the release mechanism was in the old streams, that is not really there. You can reassign the span though. So maybe that's the same thing. So that's a question about Spanstream. Okay, did we have another? Hopefully that answered the question more or less. And you can go look at the proposal. And by the way, I think Spanstream I think is implemented in GCC 12 at least, and I think MSVC's got an implementation on the way as well. Okay, somebody else was raising their hand. We didn't see any over. Yeah.
I was just going to ask, what was the reason we added contains to string and string view when we also added it as a generic algorithm?
Very good question. So the question was, why did we add contains to string and string view while we also made it a generic algorithm? Zach.
I have an answer for that.
Yeah.
Because I complained very loudly in LEWG multiple times when each of these things were added that they should be algorithms because they don't work on spans, they work on string view, that's crazy. And everyone said, you're a crazy person, get out of this room.
Okay, so Zach said he complained about them being member functions, as did the author of the contains algorithm paper. It's interesting because there's a difference of opinion here. And I actually think we should have both. And who cares if we have 2 different ways to do the same thing? We have 100 different ways already to do the same thing. This is just one more. And most of the time, if I've got a string object, I just want to put .contains on it and have, I don't want to have to remember that, oh, this one I have to do is a free function, whereas so that's just me. That's just my opinion on it. And there's also another possibility. It's also possible that string, view, and string might be able to get optimizations that might be hard to do in the generic contains. And you'll note that there's a contains and a contains subrange, which are 2 different things as part of the ranges contains.
Not as long as they have the traits.
Okay, so Marshall says, not as long as they have the traits, everything will work fine. Someday I'm going to do the lightning talk on why basic string is find is too fast for itself, but I don't know why yet. So
I was just going to say that adding this is not that big a deal because the interface to the API for basic string is already a dumpster fire.
okay, all right. So as Marshall said, string view and string have a large interface. I'll put it more nicely, nicely than Marshall
Your
did.
words, not mine.
So, in answer to the question, Ben, I'm not sure there's all the best reasons in the world. Okay, so we are down to 62 minutes. Do we have any votes for other topics that we want to talk about? Yes.
Expected and monadic interfaces?
Okay, expected and monadic, unless somebody, Zach.
Yeah, I want to hear more about the formatting container stuff.
Formatting containers. Okay, we're definitely going to do formatting containers because that's at the top of my list of what good stuff there is.
I want to hear about resize and overwrite.
Resize and overwrite. Okay. Any others? Okay, let's do. Oh, contains. This one, yeah. It just you just say you've got a string object. You just say contains quote foo or another string or a string view or whatever, and it just says yes or no.
It's like,
Yeah.
is it a substrate?
Yeah,
Yeah.
that would be another way to put it. Okay, you're not raising your hand. You're just yes back here.
User-defined ranges pipeline integration?
Okay.
Yeah, just a short word on string and null pointer. Is just null pointer permitted, or do we get a null pointer check in the constructor?
Okay, let's just do this one because it's super quick. Write that code. You'd be surprised. You could write that code by accident, right? Because, but you shouldn't do this, right? Because then, and this will compile, and it'll fail at runtime. Except for in 23, it won't compile because you'll get this error. And this is already implemented in GCC and I think a couple of other compilers. Yeah, so it's at the bottom there.
Yeah, okay, but there's no check if a car star is null.
Right. That's
No.
runtime.
Yeah.
That's runtime.
Yeah, right.
Yep. Yep.
Does it also work for 0? You can't.
The question is, can you do it for 0? This is a good question. I don't know.
Zero is a Lodestar, isn't it?
I think it's going to be, yeah.
Ambiguity?
eventually converts to a pointer type. A null pointer is a class type.
Yes.
Yes.
I knew that.
The zero null pointer constant would prefer the char star overload over the null pointer overload. And be a runtime.
For the video, David Stone answers the question, which is that 0 is preferentially turned into a pointer. Thank you. I should have asked you if you wanted to be identified for future posterity on video, but okay. All right. Yeah.
So should we add a constructor from int and delete it?
Is there already a constructor for that? It takes a size.
There may be, yeah. Yeah, probably. It's a size T, but yeah.
See previous comments about size of interface.
Right. Okay. So I think I'm starting to lose. Let's see. What was the first one? Expected. Right. Okay. Great. Okay. So let's go to expected first. So this is the fun of, big presentation. Okay. So basically, as mentioned, expected is a template type that is like optional in a way, but it's got two customizations, the return value type and the error type. And so you're able to create a function return, that has this, and you can pass back a first class error type, which is very nice for doing various kinds of error handling that are not based on exceptions. It provides support for error returns or void returns, sorry. So that means this return can be void, which is something that, I think was discussed as part of optional, but isn't part of optional. So you can do that here. Obviously, if your function wouldn't naturally return anything, that's the case where you would use a void as the return parameter. And then there's the monadic chaining functions, which I can talk about those a little bit. Like I say, I don't know for sure if they're actually going to be there. Okay, so this is an example of expected in use. And in this case, what I'm doing is I'm actually changing an exception interface into a non-exception interface by wrapping the potential exception. So if you've used boost date time, you'll know that it's all exception based. So if you do from ISO string on some kind of string which isn't an ISO string, you're going to get an exception and you're going to fall into this case. And you'll see that what we're doing here is we're doing a make unexpected, which is one of the functions that helps you construct errors. And you'll also note that I've created the expected up here with a string as the error type. So I'm just going to give you a string back as your error. You'll know it's an error because, like optional, the expected has a query to say, do you have a value? Do you not have a value? Do you have an error, for example? And so here you'll see I'm just doing a return T. So there's an implicit conversion for this time expected type, which I've defined up here. This particular example is using the Tartan Llama implementation. That's Cybrand's implementation. And so that's why you're seeing the TL there. So, and by the way, I'll mention right now, like there's God bolts and stuff like that in here. These slides are going to be up in a PDF linked form, so you can just go click on these things later on. So don't, scribble to, write down some weird God bolt string.
How is expected T void different from just optional T? Other than
Well,
API difference, does it have different?
Because you can get a first class error type that is not optional, doesn't provide you any error context whatsoever.
Compared to expected with a void error type.
Marshall, sorry.
I don't think you answered the question he asked.
Okay.
He was asking about the second parameter being void.
I don't think the second parameter can be void.
I thought you just said it.
No, the first parameter can be void. Sorry.
Okay.
My mistake if I said that. Yeah.
No, I misunderstood.
But it's gonna be monostate.
There is no monostate in expected. I'm not sure I'm repeating all the questions 100% for. Okay, was there any other questions? Okay. Okay. No, it's okay. Well, and that's the thing, right? Like all of these things, they're simple enough in theory, but they're hard. But if you go look at this, you can see like one of the first class usages of this is for something that can chain down a bunch of things and potentially return things back up, and you want to check along the way. Yeah.
Is it going to be an ambiguity question if the return type and the error type is same? Like string could be both.
Yeah. So the question is, if the return type and the other type are the same, is there an ambiguity? I assure you there won't be. That's why we're doing an unexpected down here. There's only implicit conversion to the return type. Yeah.
Is there any type erasure with the error type at all, or is it just simple value semantics?
The question is there any type erasure? The answer is with the value type or the return type or the error type?
Error type.
For the error type, I don't believe there's any type erasure at all in expected. It's just really sort of a variant. It's either the return type or the other type, and in the case of void, it's so it's something internal. Did we get all the questions? Okay, in front.
Is there a check if you try to use the value without checking if the value is there?
The question is there a check if you try to use the value and the value is not there? Yes, you're going to core dump. So I guess if you consider that a check, the answer is there's a check. No, there's no check. You have to check. Check.
Like nullable value, for instance, you're not guaranteed to actually core dump if you try to get the value. It could be garbage.
There could be garbage. It might not core dump. You never know. And that's undefined behavior land is basically where you're at. Yeah. So check for error, check for value. That's the key of this interface. Yeah.
Is there an implicit bool conversion?
Is there an implicit move conversion for bool conversion?
If it's the value and
it is an explicit conversion, but implicitly in bool context it will automatically convert. Contextually convertible to bool. Yes, that's the wording. Okay. Let me move to the next slide because there is another slide. So, in this case, this is the other half. People are asking about, should I check or whatever? Yeah. So this is how the other side of the interface looks. And if you print out this, you'll have sad trombones for the error in boost date time. But other than that, everything else on the slide is good. Okay. Let's talk about monadic functions just briefly. These are they're in a paper that is still in LEWG. I think actually the conversation is tomorrow. Did I see Inbal somewhere? Anyway, the conversation is tomorrow, so I might be taking a little bit of time off since this is actually my paper. So there's actually proposed 4 things as opposed to optional where there's only 3. For optional, there's and, then, or else, and transform. And so basically you use these to compose with other functions. So you chain together a series of functions. I don't have a slide here for the expected ones. We can go back and look at the optional ones. You can also look in the papers. So if you look in the 2502 paper, there's a link to Godbolt and a whole bunch of examples on how these stuff work together. I can tell you from professional experience that we're using this and it's really slick for cases where you want to do like serialization, right? Like, so, you've got an object, it's got, 10 attributes on it, and you say, oh, can I parse that from XML? And then can I parse the next field from XML? And then the next one, and then the next one. And then at the bottom, you've got an or else that just says, oh, if I get an error anywhere in that chain, here's what function I call to bail out and do my error handling. So it simplifies a error return based handling, not quite to the level of exceptions, but close enough. I mean, it's much closer. There's still more code in expected. I'm going to mention another thing here on video as well. I'm going to get in trouble here too. It's likely this is a slower way to handle errors. This is probably pessimistic as compared to exceptions. So I think people in the high-speed trading business are using exceptions because they use exceptions as real exceptions. It almost never happens. And anyway, there's a paper actually into the committee right now that actually demonstrates that this is a slower mechanism. And that's because you got to return stuff on the stack and do some other things. So there you go. And in the paper, there's some references to the paper and so forth. Okay, any more unexpected? We're down to 50 minutes. We're actually doing pretty well here. So I think the next one we should cover is the printing and I/O. Okay, so if you recall in C++20 we got format, and this is a way to take Python like formatting strings and create a string from data of various forms. So you could see things like this. I've got format, std is implied here, and I have two things, a string and an integer value. This is a variadic function, right? So you can have any number of parameters to the right-hand side here, but they have to match up, right, with what's in these curly braces. And in this particular case, there's a problem, right? What's the problem? Type mismatch, that's correct. Because this is saying this is a string specifier and that is not a string. So when C++20 shipped, and in earlier versions of FMT, this is a runtime error. It's an exception at runtime, okay? But in 8.1, I believe, of FMT and in C++20, because it was retroactively pushed back into C++20, now we get this. You basically, see invalid type specifier in a compile error, which actually is what you wanted all along. You knew you wanted that because 90% of your format strings are probably going to look exactly like this, right? They're in compile time, and in compile time, why isn't the compiler figuring it out for you? And the answer is it is, yes.
So the format lib is able to access the string literal as context expert?
So the question is, the format library is able to access the string literal as a context expert? Yes. And is able to figure out that those don't match and force that compile time error. Yeah.
Is the format string required to be a compile time value, or can you still give it runtime values, but you don't get the
Right. So the question is this string required to be a compile time value? And the answer is yes. When you say format, if you say v format, then you can have your runtime string and do whatever you want at whatever risk. Back here.
How significant is the compile time overhead to runtime to type check the format string?
How significant is the runtime overhead or compile time overhead to check this? In my latest checking on compile times, oh wait, no, I have no idea. I really have no idea. As far as I can tell, from using it, it doesn't do anything. But I don't know over here.
Just comment on those wondering how it works. There's an excellent blog that I think Microsoft did.
Okay.
It's like how we eliminated a whole class of runtime bugs with this.
Okay, so the comment is there's a blog from Microsoft. I don't think I have that one posted here. That might be Charlie Bartow, who did most of the format work for Microsoft. He has a CppCon talk, which I have a reference to. Watch that talk if you want to know all the internals. Yeah.
I recently flipped the switch on FMT and went from the runtime charts to the compile time charts and did not notice the compile time difference.
Okay, so Zach's saying he didn't notice a compile time difference, but measurement is king, I suppose, and just put in a few variadic templates of the right type and you'll see the compile times go. Okay, all right, so that's all this stuff here. The before after, I was mentioning Charlie Bartow's talk from CppCon 2021. Go watch that if you want to know all the internals and the details of how that was implemented. All right, so let's talk about standard print then, because this is the new facility. So you used to just say format, but now you can also just say print. That just goes to the console. Thank you. That is really nice. It's super nice. But more than that, you can actually put it in a file. You can get a file pointer and open a file and put it in, or to an O stream. So you can do all of these things now very consistently. And this is where I feel like now we've taken format out of just some string stuff and we've made it into a full I/O setup. Yeah.
Is it specified that it goes to C out, or is it specified that it goes to standard out of the process, however way it thinks?
The question is it specified that it goes out, to C out? And the answer is, in this form, yes, but in the form that I'm showing you down here, you see you can put in C error or C out. So you. Does it go through I/O streams? Oh, the question is, does it go through I/O streams? And the answer is no, it does not. It generally does not go through I/O streams, but it goes to the same stream mechanism, and it will be synchronized with I/O streams. I believe that's going to happen. That is something that's still under discussion. Not 100% sure. Zach first, then Jihao.
Yeah, I think the way it's specified is that print goes to the cout file descriptor, like C style.
Right.
And then you can also put, like he's got C error right there, but you can put std C or std C out.
That's right. This is an implied std.
If you actually use COut, it doesn't promise synchrony with std cout if you don't put std cout.
Okay, so no. This form up here will be synchronized with std cout. That is likely what's going to happen. And the reality is FMT already does that by accident. Okay, but it was pointed out as part of this whole facility's design and discussion is, if it doesn't do that, then the transition to using this while you have code that's doing cout at the same time is very troublesome, because then you can get all kind of interleaved whatever. And that's probably not what we want. And there's no performance penalty shown for doing it this way. It's faster. This is just faster than I/O streams, period, end of story, in every measurement there is. So, yeah.
Is print going to automatically add new line, or are the examples just not quite equivalent?
This one will, the one with the ln at the end, which is not implemented in FMT, by the way. But your other way to put new line in is \n.
Okay, yeah, I was just looking at the first example there, which included it.
Yeah. Slide bugs. Yeah, back here.
Can you provide character encoding for your output file?
Sorry, say again?
Character encoding. Can you provide character encoding for output file?
What kind of encoding? Character encoding. So there's a lot more Unicode capability here, and I'm not sure I know the answer to that question. This is FMT or format and print in general are much more Unicode friendly than I/O streams is at the end of the story. Yeah, it's a low bar, I know, but it's a work in progress. There are Unicode specific overloads, okay, in this library. I'm not super familiar with them, but they are there. So if you go look at the papers associated with this, there is discussion of that. In fact, there's a whole working group on Unicode to try and make sure that should work. So I think the answer to your question is yes. Not 100% sure. Maybe we should talk offline and I can point you to details. All right. So I think we've probably talked through, oh wait, I had it on the next slide. vprint Unicode, there's a way to do that. And then these benchmarks are starting to get a little bit, long in the tooth, I think, because I don't think Victor has updated these for quite some time now. But you can see as a general rule here, compared to I/O streams, you're talking, 3 times faster, sort of minimally. And fascinatingly, you'll note this one over here. That is C, friends. It's slower. Yeah.
The least letters must be the fastest.
Okay. And then, I don't know what this one is. So that's interesting. Yeah. Maybe. Yeah, I don't know. Oh, I forgot. Sorry.
I want to note that the print by default goes to std out rather than cout.
I think is what you said when you were
I think so, yeah.
We
That
said
sounds like,
various things here. So
yeah.
Is it like the same as having like DC out as a default parameter, or is the implementation free to do whatever as long as it's synchronized?
No, I think you were asking more details than we can provide.
No, not really, but
It is required to be
yeah, she has right. Yeah, that's right. It is specified. It's just, yeah,
You said that building containers will be very nice.
we're getting there. We haven't gotten to the printing ranges yet. So, okay. So it's fast. It's better. There's some links. Use FMT until it comes to your compiler. All right. See, good straight man. So formatting of ranges. So this is a facility that, you know, obviously you're going to use with format, with print. And so part of, you know, being able to usefully use ranges is to be able to actually, you know, put them out into, you know, data streams, so forth. So what you're going to see is sort of the defaults for printing out range type things. There's a couple different variations. They more or less track what you would see in sort of like a JSON kind of representation. I think that in the end, that's pretty much, you know, the decision-making process. So for things like vector, you're going to see square brackets around them. For things like map, you're going to see curly braces and things that look like, you know, objects in JSON. So this facility also includes the capability for formatting standard pair and standard tuple. And again, this is largely based on FMT. If you include the ranges.h header, you can get most of this today. I'll warn you, there may be some small differences between what's in FMT and what is finally in the standard. This paper is basically done. It's just waiting final approval from whatever the study group 9 or whatever the, you know what it is, the Unicode 16, whatever it is. Okay, one of the study groups looking at Unicode. There's some wording in here associated with that that tries to make sure that it's okay. One of the things though is, you know, for these containers or whatever, you'll have some customization ability. So if you don't like square braces around your array, then you can change those square braces on the fly. So this is what it looks like. I decided to start with a hard one. Let's do a recursive container, right? Vector, vector, string. So you got, you know, vector inside of vector with strings, and there it is. That's all it is. One line of code. Just print it, and it just does exactly what you would expect it to do, which is very nice. So vector double, of course, this pretty much takes anything. I'm not showing it here, but you can put the format specifier for your doubles right in here, and it will honor that format specifier for all the elements of that particular range. I'm showing you here things that are, of course, containers, but you know, they don't have to be containers. They can be views on containers. Any kind of range will work with this, so which is very nice. Now, you may run into some interesting differences when you actually just use sort of a view or something instead of an actual container. And now this last one is interesting, because if you've spent any time looking at format, either standard format or FMT, you know that if you have a user-defined type, you have to write a specialization for that type to be able to output that type with part of format. But interestingly here, it turns out here I have just, you know, boost static vector, and it just does the right thing. And this is FMT doing the right thing. And this is the thing that I'm going to now tell you I don't know 100% is going to be in 23. I believe it's going to be in 23 because it was brought up during LWG review that, gee, wouldn't it be nice if the standard does what FMT does? The standard as specified at this very moment does not do this. It will print parentheses instead. Yeah.
What methods are required for that? Is that just a begin and an end?
It's input. It's an input range, basically, I believe. Yeah.
Customization aside, is the default behavior consistent across platforms, the formatting?
The question is the default behavior consistent across platforms? Yes, it's going to be consistent. I should have also said that if the author of Boost Static Vector wants to write a specialization, they can still write the specialization. But wouldn't it be nice if every container in the world, from Abasale or wherever, didn't have to write that specialization and it would just do the same thing that the standard containers do?
There is one implementation-defined aspect of how format and print work, which is that when you tell it, I want a certain amount of spacing, it's going to look at Graphene Clusters within that in a Unicode context and in a non-Unicode context. And that context is determined by what your literal encoding is. In other words, the flags you pass to your compiler saying this is the kind of encoding my literals are, what your literals are. So we'll do that differently for Unicode versus non-Unicode. And that's normative encouragement, so your compiler might not do it at all. So that the white spacing might be different, but that's the only difference.
Okay, so there was a mention of graphene clusters, which blew my head off. But in truth, the TLDR of what Zach just said is that spacing may vary depending on what your implementation did because of that fact in Unicode context. I think, if that's fair. Yeah.
Format optional and expected out of the box?
No. The answer, the question was, can I format optional and expected out of the box? And the answer is no. And the question is, what would you do? So I'm not sure you're ever going to see that out of the box because it's not clear. I mean, what are you formatting, the error or the type? But I mean, it's a valid question. It's something that should be discussed. I will tell you that in an earlier version of this presentation, I said that there were some other things in the standard library that were likely to be formatable in C++23, and that is not likely to happen now, as it turns out. So things like pointers are not going to be, you can't put them into format and just have them work. So there's still some unfinished business here. I don't know about whether optional and expected it makes sense.
Did we get chronotype formatting?
Chronotype formatting is the question, and the answer is yes, that's in 20. And that's assumed here, and it works here too. So if you had some kind of a container full of time values, you could use Chrono, format specifications right there, and it would just work. And dates. Yes.
Is a set? Oh, okay. Never mind.
I wanted to go forward because we were still missing the other half of what I started, which was, yes, sets and associative containers also play in this world. And by the way, the trick that's going on here for FMT to know this is it's looking inside the definition of the range for something like the key type. Say, hey, if the key type is there, then just assume this is an associative container type, and then boom, it just does what it would normally do for the STD containers. So yes, all of these things work as you would expect. And again, I already said this, but if it turns out that this doesn't work exactly as advertised, I apologize. Okay. Let's see, were there other, I think there were a couple other suggestions, and we have actually 30 minutes left. Wow, we're doing really well. What's that? Resize and overwrite, thank you. Which shouldn't take too long. So we're going to get through more of this than I thought. Okay, so there are certain use cases where you're using a string in a context where you want to sort of replace the contents of the string without reconstructing the thing from first principles. I mean, this almost feels a little bit like some of what Dave was saying this morning, but in any case, right now you're in this horrible bind. Like, even if you know exactly what the sizes of the thing is that you want to put in, and what you would like to do with any remaining space, like maybe you want to write some kind of byte pattern or something in any extra space that you're allocating that you aren't initially assigning, then you have no way out right now. you basically have to reconstruct a new string from first principles and go from there. So this is basically going to skip a bunch of steps that would otherwise be needed. So there's extra initialization or extra copies or extra bookkeeping, probably all three of those depending on what you're doing currently. But this allows you now with a callback function, that's the operation over there, and a size to say resize my string to this new size, and oh, by the way, call this operation, and that operation is allowed to now pattern the buffer with whatever content you want to put in it, okay? And so this one has been in already in the working draft for quite some period of time. So it's really a performance thing for strings, which sounds like a funny thing because nobody uses strings for performance code, right? Of course we do. Okay. Does that help? I think.
Why is this on string and not on like vector, for example?
The question is, why is this on string and not on vector? I think vector is already going to be able to do this, right? Because I think if you say resize, it's not going to construct.
Resize reserve, but you're
Reserve.
allowed to write to the extra part.
That's right. Okay.
If you want to reserve a set of elements and then do a parallel transform into that, it's actually faster to do the resize and back inserter.
Okay.
Which is really sad.
Okay, so there's a call for maybe the same thing should be on vector. That's interesting, David.
Yes,
Hold on.
It is actually the original proposal was to add this to all of the containers.
And
then it was decided to split it up into first string and then vector, because string has more limitations on what the element type can be, specifically triviality.
Yeah, string. The elements of a string are required to be default constructed. They're required to be pod. So,
Okay.
And so vector was seen as a more complicated case, but that work is continuing there.
Okay, so the statement for the people on video is there is some proposal and work to do this for other containers as well, but this is the most trivial case, and that's the one you're getting first. Yes.
What does operation look like? What parameters?
It's a function.
What parameters or return type?
Good question. We would have to go look at the paper. I don't remember, to be honest with you. But I think it basically gives you the beginning and end of the buffer, or I think it's the buffer pointer and the size, more or less, something along those lines. Yes.
And it is expected to fill in that data.
Yes.
And I think it does return something.
It returns the size that it actually filled in.
Okay. So the commentary in the audience is always great to do a presentation here because you always learn something you didn't know because there's smarter people in the audience. But basically, yeah, it's returning you the size, and the size that was actually filled is the comment in the room. So, yeah. Okay.
Whose responsibility is to manage the non-PTR at the end?
Good question. So the question is whose responsibility is to put the null at the end, and I believe that is not going to be given to you in the fill range, and so the string itself is going to maintain that invariant. Okay. Do we have another one, or are we going to finish 20 minutes early? That's not possible.
String view that takes 2 iterators.
String view constructor has one. What's that? Pipeline. Oh, the pipeline was requested earlier. Do we have other requests?
Not quite a request, but I want to actually correct something I said earlier. The string constructor from the literal 0. Null putter and a pointer type are equally valid conversions. In practice, you end up calling the deleted null putter constructor rather than getting an ambiguity error because of some CA stuff. But passing a literal 0 will not work. It's caught up in compile time now.
Good.
Okay, so the comment in the room was that the earlier comment was incorrect, and actually if you pass 0, you're going to actually get a compile time error as well. That's a great slide update for a future thing. So pipe is next, unless there's something else. Shiha. Move only function, okay. Which you know more about than I do, but anyway, that's that's all I'll decide. Let's see where. We got to find that in the slide deck here. I believe that is going to be. I think it's down. I think it's down this path. Sorry. So I'm going to skip over all of this stuff. So let's talk a little bit about what pipe support is about. Right, so in ranges, views, and adapters, you have this same way to write two different things, right? So C of R and R pipe to C are effectively the same thing. So the pipe operator is just calling C of R, right? So this is, the range here and whatever the adapter is. So that's what they do. And yeah, so in C++ 20, there's no actual way for you to write an adapter that would interact with, say, filter view or any of the other views in STD. And that is because, let's see now, I have a feeling I lost something here in my presentation. So the long story short, I think I lost a slide here, but I'll just explain what's actually going on. So there's some deep technical stuff that has to happen for you to make what's called a range adapter closure object. That is the thing that allows you to interact successfully with this idea of the pipe operator. And so basically what's happening, and the paper is referenced here, but basically what's happening is the way that the range adapter closure object is actually created is specified specifically. It uses, I believe, if I'm remembering this correctly, it uses the MSVC version of the library, which is a CRTP-based way of actually writing this. So there were actually 3 different implementations. One was GCCs, one was Clangs, and one was MSVCs. And basically this standardizes how it's done. So now you can plug into that and you can write a very simple range adapter closure object for your view. Now, anybody tried to write a view in here? Yeah, there was one guy in the back. Okay, 2 people. Yeah, it's not an easy thing. That's an unfortunate side effect of adapters and ranges in general, that it's so hard to do. I believe there's a boost library that might help with that. Is that right? And what is it called again? STL interfaces. Yes, Zach's library, STL interfaces, helps you write like 90% of the boilerplate for the iterators, as I recall. Yeah.
I really recently wrote this plumbing to make view adapters myself for a different library project.
Yeah.
I don't understand why. I mean, so is the problem that every user is going to have to implement it themselves in one of these 3 ways? Is that why this? I mean, it doesn't seem like there's a technical reason why what I wrote wouldn't work with a standard view adapter, but I don't.
There is a technical reason why, which I don't remember the exact details of, except for that if you don't do it the same way in the different adapters, then they won't be able to work together, because you have to have an interface which specifies how that range adapter closure object happens. And that's really what's being specified in this new paper. So, yeah. And yeah, I don't know what happened to the slide. So, was there another hand somewhere? Okay, and I think we have move only function was the next one. Apologies for that. And this is a one-slide thing, unfortunately. So move only function is a lot like standard function. But as advertised, it's meant for movable callable objects. And it's a wrapper. It can call, a member function, a regular function, even though member functions are not functions or something. I don't know what but it has a number of improvements over STD function, including improved cons correctness. And so this is actually also, it's implemented in GCC 12 and MSVC already. And, it's just an addition to functional. And I think in large part, you can think of it as a drop-in replacement for standard function that might be slightly more efficient and more correct for things like cons correctness and maybe a couple of other things that are buggy relative to STD function.
It's necessary when you have when you function when you capture in your function something by reference, then you can't copy it into the lambda of another function.
Okay, so
now we can move on.
So the comment in the back is if you capture your function by reference, you absolutely require this because you can't copy it at that point. David.
So is move only function itself, is it always move only? Does its move onlyness depend on the move onlyness of the function object?
So the question is, does it depend on the move onlyness of the function object? And I believe that if your function object is not movable, this will fail to compile.
Yeah, I mean, if the function object that you're wrapping, if it's copyable, will move only function itself be copyable?
If it's copyable,
no, it's type
no, it's type raised.
No way of knowing.
Yeah. Yeah.
Okay, so move only function itself is always move on.
Yes.
Hope so, with this name. Yeah.
Well, so it did not always have this name. It used to be called any function. Any invocable, right? It had other names, right? It was pretty much the hell of naming in the standard committee that you could ever go through, and I'm sorry for the two guys that had to go through it. Yeah.
Does it mean if I write a function that has a standard function as a hook, basically? So should every library code like this be generalized to use move only function instead?
Yes. If you don't need to move it, then it increases the set of functions that can be used with your library.
That's right.
If you don't need to copy about it.
Right. So the comment in the back is, should you generally use this instead? And the answer is, if you don't need to copy for some reason, then yes. Okay. Passing parameter. Okay, we have 17 minutes left, and I am going to make a suggestion unless somebody else has something they really want to see. Not flat map. Sorry, Zach. Flat map is too boring in 2022. Let's see here. Try and get to it. Let's talk about these, because I think these are of general importance and usefulness. Now, this set of proposals comes from 1206, which when you go read 1206 is all about this fancy thing called ranges : 2, right? So you've got some big set of pipeline stuff that you're doing, and then you say ranges 2, and you get a vector constructed automatically for you, for example. Very slick, very cool. But the reality is that none of this stuff is dependent on any of that high-level fancy ranges stuff. This is just straight up new methods on the container types that are incredibly handy to use, especially when you're working with other ranges of various kinds. So depending on what kind of container you have, you'll get a different series of operations. All of them will have a constructor that allows you to now construct from, and that's what ranges 2 uses. It uses this tag dispatch from range T. But you could call this constructor yourself. You don't need to use the ranges facilities to do that. And this is where I think what we're now seeing is we're seeing the full extent of ranges coming into the library, right? We're seeing, basic containers and so forth actually now being adapted to actually be able to, use effectively other ranges in a way that we just didn't have in C++20. And, this just cleans up a lot of code to be able to construct a container from a range, or importantly, like with vector, being able to append to the range a whole nother range. Now, if the ranges are sized and so forth, you might actually be able to get some efficiencies out of this as well. If you have a deck or something that allows prepending, not with vector, you'll be able to use prepend range, and you'll also be able to use insert range. So these are some of the operations that you're going to get. If you look at, here's a sort of contrived example, but let's say I've got a span of chars and I want to construct a vector of chars. I can say, construct it from a range, and then, by the way, this is in namespace std, and then you can say append to the same range. And as you said, no prepend for vector because its class of container does not allow that to actually happen.
Joe?
Yes.
So are these member functions being added to all standard containers?
Yes.
Appropriate?
As appropriate. So associative containers get a different set of facilities from sequence containers and so forth. And adapters too, not just the containers, but also the container adapters. Yes.
I just looked and you get all new deduction guides too, which is nice.
And deduction guides, yes. So yes, so you can write some stuff. Now, by the way, this is what this is the feature that this thing is encapsulated in, right? Here's some, tricky code, as it were, fancy code that says take a forward list that has, take a list that has a forward list of integers and create a vector of vector events from it. And you'll notice on the second one, it's actually creating a vector of deck of doubles. So it's converting the base type, since integers are convertible to bool, and so forth. In this case down here, we're doing, an iota. So you're going 1 to 42, and you're just putting that in the vector vec. Yeah.
Does ranges 2 work with containers that do not have the from ranges constructor overload?
The answer, the question is, does ranges 2 work with containers that do not have the from ranges overload? And I believe the answer to that is no. So I don't think you'll be able to take a boost vector off the shelf, but I'm not 100% sure. There's actually, let's go to the back first because I think you were first.
Is there a way to detect the conversion from int to double if that happens to be something you want to avoid?
Oh, so the question is, could I prevent this conversion? Not that I know about, because this is the bad old rules of C++, right? I mean, if you've got your own types in there, then absolutely, right? You can make all the things, the constructors explicit or whatever. So I think Jihao was first.
So if the container has a range constructor, no matter it's implicit or explicit, it can work, unless the type registers itself as a view.
Okay, so the comment is that it can work regardless if it's implicit or explicit, unless the type is registered as a view, but containers wouldn't be registered as a view, right? So,
So anything doesn't matter whether it's container or not.
Okay.
So I have a question about deduction guides.
Deduction guides,
So
yeah.
you have could you say auto vec 3 there equals ranges : 2 open bracket std vector close bracket open paren this close bracket.
I have no idea. Maybe.
And that's what you want.
Maybe.
You want to say, I want a vector of this.
Yeah.
What result would you be expecting there?
A vector of vectors of x, just like in vec 1.
Generally what happens with the deduction guides, right, is the deduction guide is going to take, this.
You might get a vector of listed.
Yeah.
It feels ambiguous to me what you would get out of that.
Some to play with and find out.
It would be nice if I had it. So I think there was a question over here before I go over here. Yeah.
So is it easy or even possible to add from range overloads to our custom containers?
So the question is it easy to add the overload? I'd say absolutely, it's trivial. Basically, you just add, if I go back to the other slide, right, basically that thing is an object in STD, which you can access, right? It's called STD : from range. This is a tag dispatch thing, I think. I don't know, Inbal probably talked about that today. I didn't go to her talk this morning, but in any case, yeah, this is a standard thing, no problem at all. So yes, Boost and everybody else could add these things. Actually, I'm hoping that, you know, in some of the Boost container libraries we'll get this. I'd love it if I had enough time to make the pull request myself, but I don't.
And just to be absolutely certain, there's two different versions of this. One that takes a template constructor, or a template container, or template of a container, and one that takes the exact container. So in those first two examples, they're fully specifying what the container is, and in the second one, it's just std vector, a template.
I think that's the same question I asked. You wanna answer?
Which one is the second one? This one?
Yeah.
That's a template. Yeah.
Okay.
So yeah, actually this one probably is using a deduction guide, right?
It is.
Yeah.
I didn't read part of it.
Yeah. Okay.
So, and yeah, if you did that for the thing I said about 3, you'd probably get a vector of forward listed in.
Yeah. Okay, was there another question? I think you had a question.
Does this work all right with the like const iterator processing that you have to do with filter? I presume so.
So the question is, does this work all right with the const iterator nonsense associated with filter? It's a good question. I think it's fine. But
like it could potentially hide all of that.
Const is this very problematic thing. There is another addition here which I have not talked about, and actually needs to go in my slides, but there's an as const view. So if you have a problem where maybe you want to force it to const, you can use that. There's also a I can't remember now what the name bike shed wound up, but there's also a move view. So for moving stuff. So there's a few other facilities in here, which I tend not to talk about because I feel like a lot of times you just don't need them. And, you know, if you're, you know, smart enough to work with this stuff and need that, you're going to know anyway. So, yeah. All right. We have 7 minutes left. Does anybody else have a topic that they would like to see?
I'm curious about the C wrappers if no one else has anything.
C wrappers and flat map. Well, we can talk about flat map for 30 seconds since it's right here on the screen. And then we'll do the C wrapper stuff. I think we have time for both. Flat map is nothing new, honestly. I think it's been in Boost for 3, 5, I don't know how many years, forever. There's various versions of them floating around. Actually, the proposal has been in work for 3 years.
Does this store the keys contiguously and the map values contiguously rather than a contiguous series of pairs?
So basically, that's correct. So basically, the idea of flat map in general is you're separating the keys in the containers, but from your point of view as a user, you really can't tell that because everything is still done in terms of, I mean, it's basically a drop-in replacement for STD map, but there's no node container here. So everything is built by default on vector. You can replace those container types if you'd like a different container type. Now, if I remember some of the performance aspects of this, one of the interesting performance aspects is that a lot of times what you're doing with maps is you're looking for something, you're looking for a particular value, right? And so it turns out that by having a contiguous container of the keys and doing that, you're going to have the keys hot in your cache. And by the way, the keys may very well be much smaller than the data that's actually mapped because you might have big objects over there as opposed to some key values. And so it turns out the lookup case, you know, gets dramatic optimization. Your mileage is going to vary with this. I can tell you, having done performance tests on Boost flat map and other flat maps, they're different. And by the way, there are unordered flat maps in the world, believe it or not. And anyway, so just know that. But yes, the underlying representation of the containers is different. This is actually a container adapter. So it's not actually a container itself. Okay, I got a question over here.
So
the boost flat map does store
Oh,
a
wait.
sequence of pairs, right? Okay.
Oh, is that how it does it? Okay. Yeah, so it's a little different. It's a little different from this design then. Yeah. Okay. Yeah.
My question is strictly related. So is the iterator points to a standard pair or a standard pair-like thing which has first and second behave weirdly?
It's a pair of reference types.
A pair of reference types. Yeah. This is what's that? What's that? So this is where zip comes in, where like if you want to put these two containers back together, right, zip is a good way to do that. So I think before you, I have, okay, all right.
If you interface, can I use it as a drop-in replacement for a boost flat map?
Yes, mostly. So the reason I say mostly is there's undoubtedly a few things that you can do here that you can't do in boost flat map, and that the vice versa is probably also the case, but I don't know every single method on boost flat map, so I can't say 100%. Yeah.
So,
Zach.
All the operations should be faster than boost flat map, even just iterating, because boost flat map stores things in heap order, not in sorted order, and if you just rip through them in order, it's just hot and cached all the time. So
Right.
every operation should be
So the comment is this design should be faster than boost flat map, which is a good thing because boost flat map in certain cases is not that great. So one other thing I'll point out about this, we got 5 minutes left, but boost flat or the flat map design here has again this tag type design on the constructor where you can provided a couple of containers of already sorted keys and maps, maybe even at const expert time, right? So you can provide all of this right up from the beginning, and then no sorting or anything will have to happen to get the invariance to hold, for this particular case. So that's the kind of extra thing that you don't get necessarily, yeah.
Can you pop out the key container or the value container?
Yes, the question is, can you pop out the key container or the value container? And the answer is yes. I think it's called extract, if I remember correctly. So you can extract it, rewrite it, reinsert it. So you can do some nifty stuff or dangerous stuff, depending on how you look at it. Yeah.
Will it work with a small vector?
Will it work with a small vector? Answer yes. Yes. Small vector, that's one of the things we still need to put in the standard. Because yes, small vectors are incredibly handy. And sorry, what was the C interfaces?
What are the exception guarantees on
Oh God. So the question was, what are the exception guarantees on flat map insertion? The guarantee is that it might erase your container. If it's going to leave the two containers in an inconsistent state, it's all off and it can erase your containers. I'm serious, that's what it is. It's a horrible thing. So don't have, it holds the invariance all the time. Just don't violate the inherent, don't have exceptions in construction. Okay.
He was asking about insertion, not construction.
That's true, but it's insertion, construction of the things in the insertion, right? Okay, so sorry, it was the out pointer, in pointer, was that what? Okay. Okay, so the general idea here is that when you're interfacing with C APIs, a lot of times you get a pointer, which you're responsible for, right? So, and when you look around and you try and write like a deleter and unique pointer or something like that, maybe to handle that case, yeah, it turns out you can't really do it well. And so that's what these facilities are for. So there's two different pointer types here. One is out pointer and one is in out pointer, meant to handle the two cases where you're going to provide a pointer in and get data out as well as the out pointer. So, and basically the expectation here, is that what you're going to get out of this facility is going to be on par with your hand-coded variations of these things. So the nice thing about it is basically you can use a unique pointer, for example, with a C pointer and have it manage the memory for you. So here's a simple example of a file open. And you basically want to create a deleter, which is going to get called. And you're going to use this particular example. So you're going to put a deleter into your unique pointer. And where the out pointer comes in is you use that unique pointer and you wrap the out pointer in a standard file pointer in the standard call directly in the fopen. Okay, so to the C, it looks just like a pointer, but you're giving it a unique pointer, and it's all right there, exactly as you would expect. So, you know, if you get a throw somewhere down here, then it all just cleans up automatically, and that's it. We have 29 seconds left. Actually, it was way more than 5. I lost count somewhere, but so I think yes. Let's. Yeah. Oh, I'm overtime. Okay. All right. Well, thank you very much. Appreciate it. Come and ask questions later.